Hello, this is Mishra from Shahid Rajguru College of Applied Sciences for Women from University of Delhi. Today we are going to perform an experiment using this apparatus called spectrometer. So before going to perform an experiment, we should know about the apparatus as well. First of all, let us introduce this sodium lamp. This is the sodium lamp transformer and this is the sodium lamp table. As we connect this transformer to the sodium lamp table, so we get the sodium lamp. Now come to the spectrometer. This is the prism table. We can adjust this prism table by using this adjustment screw and we can adjust in upward and downward direction. This is the collimator of the spectrometer and this is the slit. This is the adjustment knob which is known as slit adjustment knob. You can adjust this slit of the spectrometer by using this adjustment knob. This is also an adjustment knob which is known as rack and pinion screw. You can adjust the slit as narrow as you want by using this adjustment knob. It has a rotatable table and two vernier scale, V1 and V2. We can initialize the reading of the vernier scale by using this rotatable table. Let us come on this part. This is called the telescope of the spectrometer and this is the Ramsden eyepiece of the telescope. We can adjust the Ramsden eyepiece by using this adjustment knob which is known as rack and pinion screw. By using this screw, we can adjust the Ramsden eyepiece so that you get the clear image of the spectrum or the object. You can adjust this as you want. Now move with second step. In the second step, we have to determine the angle of the prism A. To calculate the angle of the prism, we have to determine the reading in left and in right direction. Forget the reading in left direction, move the telescope in left until you get the clear image of the reflection of the slit. When you get the clear image of the reflection of the slit, stop moving the telescope. Here I am getting the clear image of the reflection of the slit. So note down the reading of the vernier scale. I am considering here that you can able to note the reading of the vernier scale. Note MSR, VC and total. For V1 and V2, you have to consider the reading of both vernier scale V1 and V2. Similarly, move the telescope in the right until you get the clear image of the reflection of the slit. When you get the clear image of the reflection of the slit, stop moving telescope and note down the reading of the both vernier scale V1 and V2.
After taking the reading from the vernier scale, you have to determine the angle of the prism A. For this, you have to make this type of table. In this table, there is MSR, VC and total for V1. Similarly for V2 in left direction, MSR, VC and total for V1 and V2 in right direction. When you make this type of table, you have to make the second table. In this table, you have to calculate the angle of the prism finally. For this, take the difference of the two readings V1 and V2 and use this formula to calculate the final prism angle.
Now move on the third step. In this step, we have to calculate the refractive index of the material of prism. For this, move the prism in left direction so that its rough surface is towards left. Similarly, move the telescope in left until you get the clear image of the spectrum. Here I am getting the clear image of the spectrum. Now note down the reading of the vernier scale V1 and V2 as you done before.
Now coincide the vertical cross wire to each color and take the reading V1 and V2. When you get the reading V1 and V2, you have to put that reading for the direct position. Similarly, put the MSR, VC and total for V1 and V2 so that you can determine the angle of minimum deviation. After that, you have to make the second table. In that table, you will able to calculate the angle of minimum deviation finally. This is the second table in which you have to put the difference of the two reading V1 and V2. Use this formula to calculate the angle of minimum deviation finally. When you calculate the angle of minimum deviation D and angle of the prism A, you will able to calculate the refractive index of the material of the prism. By using this formula, Put the value of A and D for the respective colors and you will be able to calculate the refractive index of the material of the prism of that color. Here, mu is the refractive index of the prism, A is the angle of prism. For equilibrium, prism is at 60 degree. D is the angle of minimum deviation. Now, finally, you will get the final result. In the final result, you will calculate the refractive index of the different colors: violet, blue, green and red.
For more details, please refer our manuals and presentation so that you can understand more clearly. Thank you.